Okay, so the last time we used the static equilibrium method to solve for some of our reactionary forces on our truss problem. Now we're going to get into the method of joints. But you might notice prior to doing that, we need to kind of come up with a couple of things. And we need to first find out what some of our angles are here. So you'll notice we got an angle. We'll call this angle theta, and we got this angle over here. We'll call that angle beta. So for lack of anything better to talk about it right now. And we need to determine what both theta is and what beta is. Now, if you recall, we're going to use trigonometry for this, and we've got some of our dimensions already here. So we'll start here with theta, and if you remember your trig functions, we have the sine of theta equals the opposite over the hypotenuse. The cosine of theta equals the adjacent over the hypotenuse. And the tangent of theta equals the opposite over the adjacent. Now, it doesn't have to be theta. It can be beta. It can be gamma. It can be iota. It can be whatever you want to name that angle. But in this case, in most math classes, we use theta just as a common one. So we're going to do this. Now, you'll notice in this particular problem up here, so we're finding this angle right here at joint A. So if we go the sine of theta, that's going to equal the opposite, which the opposite side from theta is BD, over the hypotenuse, which is AB. So let's replace that out. BD is 4 feet, and AB, we don't know what that is. We have no idea. So not a good one for us to check. However, I do know AD and BD, so I know the opposite and I know the adjacent. So let's go ahead. The formula we have to use here is tangent of theta. So tangent of theta equals the opposite, which again is BD, over the adjacent, which is AD. So, and both of those are 4. So 4 over 4, which equals 1. Now, if we have tangent of theta equals 1, we have to take the inverse tan. So theta is going to be the inverse and a 1, and we're going to find out that basically this is going to be 45 degrees. If you didn't know that before, 4 feet and 4 feet, in order to get that is going to be 45 degrees. But as we go, the inverse tan of 1, or got to remember your keying sequence depending on whether you're using a Texas Instrument or a Casio. So 1 inverse tan is 45 degrees. So theta here is 45 degrees. Okay, let's do the same thing over here now, and only instead of using sine of theta or cosine, we're going to be using the beta. And again, we have the opposite, but we don't have the hypotenuse. We have the opposite and we have the adjacent. So we still need to use, in this case, the tangent of beta equals the opposite, BD, over the adjacent, which is DC. So, replacing this, BD is 4 feet, DC is 5 feet. So, tangent of beta is going to be 4 divided by 5, which is 0.8. So then we'll take the inverse tan, and we find out that beta is 38.66 degrees. So beta here is 38.66 degrees. 38.66 degrees. Now, one other comment about this while you're using your calculator that you need to do. Make sure that your calculator is in degrees. A lot of times, if you're in radians or gradians, you're not going to get the right answer. So you need to make sure that the mode right here on your calculator, if you got a TI-30XA like I do, it's right here. But you got to make sure that it is in degree mode, not radians or gradians. That's something completely different. So there is step 2 of solving our truss problems. In the beginning of the method of joints, so actually let's just call this step 1 on the method of joints, and we'll say that is determining these angles here. So, and of course, if you wanted to just go back and double check, you could of course check your math by plugging in these numbers into any of the other trig functions, and you would be sure to double check your work that you've got it. So there is step 1 of the method of joints. Determine the angles in your truss.